Greetings to you all, fellow brothers and sisters. This is Elijah, the prophet, according to Malachi chapter 4, verse 5 to 6. Behold, I will send you Elijah the prophet before the coming of the great and dreadful day of the Lord. He will turn the hearts of the fathers to the children, and the hearts of the children to the fathers, lest I come and smite the earth with a curse. AKA, Temper the Great Physician. I was basically a learner and a tutor at the same time while I was at the secondary school. What we have to understand, my precious brothers and sisters, is that I am one of these boys who are a maths and science junk. I used to practice maths and science more than any other subject. Actually, I did not care about the other subjects. I was only practicing maths and science day and night. I am actually a boy with a vision of mankind and passion for science. But though I am lost in all complications of the earth, I hide behind my books because I feed on knowledge. Then I am able to sleep at night with my eyes closed. So, my precious brothers and sisters, during my school days, I was struggled above my peers in science and did not mind to help my fellow brothers where they had challenges, because I understood that God wants us, all of us, to be successful. But to be successful, there are many ways to be successful. It is not only maths that can make a person successful. Actually, yeah, there are many ways to make it, but to the varsity students who are at first year, I am here for them. As you can see, I am the Vice Chancellor student from the University of Mpumalanga. I am doing Bachelor of Science General. Actually, right now, I want us to revise calculus. Actually, today, the lesson that I want us to do is implicit differentiation. Yeah, actually finding the dy over dx in an equation that has two variables, x and y. Yeah, actually finding the derivative of an equation that has two variables. It may be x and y, q and r, w and r, z and x. But however, in mathematics, we like to use x and y. So, my precious brothers and sisters, what you have to know about implicit differentiation is that this way of finding the derivative or the gradient of a function, it, it is a little bit complex in that it involves many things. For example, for you to be able to apply the implicit differentiation in an equation that has two variables, x and y, to find dy over dx, number one, you need to know how to apply the product rule, finding the derivative of a product of two functions together. And also, you must know the quotient rule, finding the derivative of a quotient of two functions f divided by g. You also have to know the power rule from grade 12 metric, and also the chain rule, which was first introduced at varsity first year level, finding the derivative of a composition of two functions, which is the derivative of the outer function evaluated at the inner function multiplied by the derivative of the inner function. So, precious brothers and sisters, what you need to understand is that from secondary level, I was not stingy with information. Actually, I would like to take over and teach as a teacher, as I have said, at my secondary education, actually at FET from grade 10 to grade 12. Actually, I had this thing of brotherly kindness. I felt like the way my teacher was explaining it, my peers, my brothers did not understand it very well. So I wanted to put it in a way that everyone will understand, specifically my brothers, because my ministry is the ministry of brotherly kindness, but also the sisters as well. Yeah, precious brothers and sisters, as we have said today, we will be doing implicit differentiation. As I've said, okay, implicit differentiation, you have to understand those things that I have mentioned. We will do it right now, my precious brothers and sisters. What I can add also about implicit differentiation, yeah, is that in implicit differentiation, when you are finding the derivative in the equation, dy over dx, you must know that whenever you come across any variable that is not x, because now remember, dy over dx means you are finding the derivative in terms of x. Actually, you are finding the derivative of an equation y is equals to, and you are finding the derivative with respect to x, the derivative of y with respect to x. So make sure that whenever you come across a y variable, don't forget to take in a dy over dx to indicate that now you are finding the derivative of a y variable with respect to x. Okay, let us start, my precious brothers and sisters. Yeah, let us start. Actually, number one, as I've said, we can't go straight to implicit differentiation, guys. We have to start by the basics. Number one, I would like us to revise. We can revise number one, the product rule, guys. The product rule. Finding the derivative of a product of two functions together. What we have to understand is that the product rule states that the derivative of f and g, f multiplied by g, is equals to the derivative of f multiplied by g plus f multiplied by the derivative of g. Meaning, if we have a function p at x is equals to 20xy. To find the derivative of p at x, number one, we can separate this function p into two separate functions, f, which is 20x, and g, which is y. Then we need to find the derivative of f and g with respect to x. That means we are finding f prime. F prime is equals to, by power, is equals to 20. We are finding the derivative of an x variable with respect to x. Hence, the dx and dx will cancel. Then it means f prime is equals to 20. Then we can also find g prime. G prime is equals to the derivative of g, which is equals to y. It will be equals to 1. Since y is raised to the first power, g prime will be equals to 1. Then since we are finding the derivative of a y variable, we must not forget to take in a dy over dx to indicate that we are finding the derivative of a y variable with respect to x. Then now we have everything, guys. We can now find the value of the derivative of f and g, or p at x as a whole, because we know the formula is the derivative of f multiplied by g plus f multiplied by the derivative of g equals to f. The function f, we said it's 20x. The function f is 20x, then f prime is 20. Then g is equals to y plus f is 20x, g prime is equals to dy over dx. Then you can see already we have applied the product rule. This is simple. Then now we know that means p prime x is equals to 20y plus 20x multiplied by dy over dx. So guys, this is the product rule. It is not difficult, guys. It's simple. Remember, for you to apply implicit differentiation, the product rule is a basic. It's your basic. What I used to tell my student that mathematics is a game. In account, for you to play the game, you have to master the rules, guys. And for you to master the rules, you need a routine. Okay, let us do another example of the product rule. We can take p at x is equals to x cubed y squared. Okay, let us find p prime x. What is p prime x? Okay, we will apply the product rule because here we have two functions, f, which is x cubed, and also g, which is y squared. Okay, f prime, our f prime here is equals to, okay, according to the power rule, 3 multiplied by x raised to the second power, then g prime is equals to, by power rule, 2 multiplied by y raised to the first power. Then since we are finding the derivative of a y variable, we must not forget to take dy divided by dx. That means our answer is 2y multiplied by dy divided by dx. Then now we can find the derivative of p at x, p prime, now using the product rule, because the formula is simple. The formula is, okay, the derivative of f and g of a product of two functions is equals to f prime multiplied by g plus f multiplied by g prime. Our f is x cubed, our g is y squared. F prime is 3x raised to the second power, our g is y squared, plus f, it's x cubed multiplied by g, it's 2y raised to the first power multiplied by dy divided by dx. Then guys, this is p prime. This is our p prime. P prime is equals to 3x squared multiplied by, okay, as simple as it is, guys. This is simple. Can you see? Then now we are done about the product rule. How about the quotient rule? My precious brothers and sisters, how about the quotient rule? Okay, let's say we have the function p at x is equals to x cubed divided by y cubed. So what we have to understand is that according to the quotient rule, the derivative, according to the quotient rule, the derivative of f divided by g is equals to f prime multiplied by g minus f multiplied by g prime divided by g squared. This is the definition of the quotient rule. Then if we have this function x cubed divided by y cubed, it means our f at x could be x cubed, then our g at x could be y cubed. What does it mean? It means f prime is equals to 3x raised to the second power, then g prime is equals to 3y raised to the second power. Then don't forget to take in dy over dx, since you are finding the derivative of a y variable in terms of x. Then if you have f and f prime, g and g prime, it means you have everything. You can apply the quotient rule. You can find the derivative of these two functions, x cubed divided by y cubed, according to the quotient rule. Okay, your f prime is 3x raised to the second power multiplied by g. Your g is 3 is y, it's y cubed, then minus f, it's x cubed, g prime, your g prime, it's 3y raised to the second power multiplied by dy divided by dx. Can you see, my precious brothers and sisters? Divide by g squared. Your g is y cubed. Then you are done. Yeah, you are done, brothers and sisters. Then it means you are halfway ready for us to apply together the implicit differentiation. Let us continue what we started. on the next video, my precious brothers and sisters.